Oh boy, oh boy. So let's talk about some of the probability formulas, all right? And I'm going to do my best to go into depth with these without spending a whole lot of time. So really and truly, there are four main probability formulas. So let's talk about the first one up in the left-hand corner. Mutually exclusive. So we're talking about or, right? One or the other. Well, that means that I can have one thing happen, but if that one thing doesn't happen, I have a second chance. I have another thing that could happen that still gives me a win, right? So for example, if we're talking about playing cards, which I obviously love doing, if I have mutually exclusive events, I can draw a king or a queen from the deck and I can be a winner. So that means any king or any queen makes me a winner. I don't need a king if I get a queen and vice versa. I don't need a queen if I get a king, okay? So the way that we figure this out is the probability of A or B is the probability of event A, which would be drawing a king, plus the probability of B, which would be drawing a queen. So for example, in a deck of cards, a normal deck of 52, there's 4 kings and 4 queens. Well, if I just needed a king, that's 4 out of 52. Certainly really bad probability anyway. But if I needed both, meaning mutually exclusive, a king or a queen makes it 8 out of 52. It doubles my chances of being a winner, okay? So that would be one representation of mutually exclusive. If it's an or, I can take both of these, okay? Now, keep in mind something. You might see it written as the probability of A union B, okay? And union being or, right? So union means I can do either one of those things, okay? Overlapping. Okay, so overlapping happens a lot with two-way tables, right? It also happens a lot with decks of cards, but we'll get into that in a minute. So overlapping means the probability of A or B, right, is the same. It's the probability of A plus the probability of B, but you've got to subtract out the chance to duplicate something, so chancing of the overlap. My point being this. Well, what if I wanted to draw a king or a diamond? Well, drawing a king or a diamond, I can still draw one or the other, but if I had the king of diamonds, it's way different. Okay, so I can't get a king if it's a diamond because I have to subtract that overlap out. Because getting a king that is a diamond is one of those chances that would duplicate my chances. I can't have that. So I would have to take 4 and there's 13 diamonds. So, but it's not 4 plus 13 to get 17 because I'm duplicating the king of diamonds, which is a diamond. So I'm going to have to subtract that one out, okay? So I don't have a 13 plus 4 chance making 17. I have 16 out of 52 chance because I can't double count the diamond that is a king, all right? So I have to take out the overlap there, all right? Independent events. So we talk about compound probability a lot. The probability of A and B happening, right? Or the probability which is the intersection, which is the probability of A intersection B. Okay, so that's an and. I have to multiply those events of happening. So I need to have one right after the other. Drawing a king and a queen, meaning if I have 2 chances, right, because my subset is 2, a king and a queen, I need to draw a king and then a queen, in that order. That means my probability is way harder. So think of it like a deck of cards, right? So you have a deck of 52. The probability of you drawing a king or a queen would be 8 out of 52. Pretty decent chances. Not great, but pretty decent. But drawing a king and a queen means the first card I pull off has to be a king, and the second one I pull off has to be a queen. That's astronomically harder than pulling a king or a queen, okay? So that's why we multiply those things, because it makes it astronomically more challenging to get. So the probability of A intersection B, or and, meaning they both have to happen, is the probability of A times the probability of B, or the probability of choosing a king times the probability of choosing a queen, okay? Now, that's with replacement. So for example, let's do the king and queen situation. So drawing a king would be 4 out of 52, right? So I have to draw a king. That's gonna be multiplied by, I'm replacing that card. So I still have 52 in the deck, and I have 4. This is a huge number. The chances are terrible for you to actually do that, okay? Not good. Now let's go about dependent events, meaning without replacement. So it depends on what I choose the first time because I can't replace that card, okay? So the probability of A and B, again, intersection, A and B is the probability of A times the probability of B given that A happened. So before you even get into the actual number, I have to make sure that A happened. Because if A didn't happen, then it doesn't even matter, right? So it's kind of the same idea. I have to make sure that I actually got A, or a king chosen first, even to get to the next level. Okay, does that make sense? So I need to make sure that with that replacement, that works. So the probability of drawing a king will be 4 out of 52. Given that I drew a king, and I'm not replacing anything, there are 4 queens in the deck, but now I have only 51 chances to get that, okay? But again, that matters a lot because I had to choose a king first, or this doesn't even matter, all right? So longer video, but I hope that makes a little bit more sense. I'll get into some of the probability with the division a little bit later. See ya.